In a previous little bit of video, we saw an example of how one might build up a Bayesian network to keep track of individuals as they're passing through occlusions, either in front of each other or behind obstacles as part of a tracking. So we've detected the objects, we're tracking them, and then the tracking gets confused because of these occlusions. What we're going to look at here is an example of how we can apply this Bayesian network approach to actually resolving some tracking. It gives us an idea of how well it works. So here's a couple of frames from this video. So this is an outdoor video, and we're watching pedestrians and cars moving back and forth. And unfortunately, I don't have the original video to show here. I can just sort of show you the results from the paper. But these are some sort of typical frames from that video. And as you can see, right here we've got a couple of cars that are detected, 1 and 2, and a couple of pedestrians, 3 and 4, and ultimately more pedestrians and cars appear. So if you recall from a previous lecture, we could do this sort of space-time plot where we looked at the target position as a function of image position and also of time. And we sort of simplified that a little bit here, just showing its horizontal position in the image and then the time right here. And this gives you some idea of the different trajectories that we've got going through here, and the different targets, and then how they get close to each other, and then there's occlusions and things like that. And altogether we ended up with 34 different segments where some target was tracked sort of continuously right here. Now you can kind of get a feeling for a little bit of what's going on here. You can see, this trajectory here, it looks, like the person is sort of moving in a straight line or something like that. So potentially there's just a couple of people that are sort of crossing each other, and because of occlusions, things got a little bit messy when they kind of crossed in front of each other. Well, we don't really know here, and that's where we're going to use some of this sort of tracking type technology in the Bayesian network, this Bayesian network type formalism right here, because it keeps track of the colors. It helps us identify which target is which. Well, when we apply that network, and we saw the network, the actual network that was developed at the end of the previous lecture segment, we get a result that looks something like this. And you can see here in the color refers to the persistence which has been maintained by matching up the different colors. And so this will be one person, and this is another person. They get close together, and I don't know what's happened to this person. Maybe this person is actually walking off in a different direction. Getting down here. Here the two people get close enough together, they get a bit confused, and maybe one person has more strong colors or something than the other, and so the trajectory here gets confused with the first person, but ultimately later this trajectory reappears and they can reassign this identity with that identity. And it sort of makes sense. You can see that the trajectory suggests that the two are crossing in front of each other. Here's a case of where it works a little bit better with the purple and the cyan. I'm not quite sure what happened here. Maybe the person stepped into a shadow and they thought, then maybe this is a new person, or maybe it stepped behind some sort of obstacle and a different person appeared. Some people came down here, maybe they met together, although just looking at their trajectory suggests that this person went straight and that person went straight. When you actually look at the colors, that suggests maybe the two people met together, and when it went off in this direction and the other went off in that direction. So you see how it can go here. So what we've been looking at here is an example of how we can use a probabilistic approach to maintaining this persistence, even though the trajectories might get broken up, either because of tracking failures or because of occlusions. It's all based really on a little bit of simple evidence, that of the trajectory and also of the color of the targets, basically the color of the clothing that they're wearing. When targets get close enough together, when people are sort of shaking hands or just standing there talking to each other, that's one of the places where the tracking algorithms often break down. They often merge detection and merging. Detection and tracking merge the two people together into a single target. And that could be a topic for some future research, that how to identify, even though the pixels are all sort of jammed together, more or less, which pixels belong to the original person and which pixels belong to the new person. Anyway, thank you very much.